Hello, class, and welcome to our first week content. So here I'll review a few things about this first week chapter that we're going to cover from your textbook, exploring the network, just a basic introduction, basically, um, that you'll go over. So just an overview and what the chapter is all about. Starting with the network today, please take the time to watch the video. Very, very funny one. How help desk people can be. Take a second to watch it. I'm not going to waste your time to watch it. Same thing with this one. The network today, communication um, is as important as anything else in life today. Connecting to everything that we do on a daily basis. Think about it. There's not much that we use that does not have some type of connection to the internet, connecting to some type of network, connecting to some type of data to retrieve and put information. So technology today, imagine if we don't have the internet today. Most of you are probably youngish, so you were born with this technology. In my days, we had nothing. We had basically a old way of sending and receiving a simple, basic, like notepad document. We didn't have what we have today. Um, the Google, the YouTube, the instant messages that you guys have, your Facebook, your Twinkie. I'm sorry, your Twitter. I'm always thinking about Twinkies. My bad. So it's just how the world evolved in the last, since the mid 90s, 2000s to today, how it evolved and how many users do we have, and the expectations of where we're going to be with the internet of everything that we use today, cities being connected together, using basically anything that we have to connect through the internet. So internet of everything. Also, it's a short video, just a couple minutes. Take a minute to watch it. Pretty interesting. Networks support the way we are, that everything school, you guys are taking a online course, and right there, distance learning, you'll be able to connect from anywhere on your computer. Gaming industry, communication, work, businesses with COVID, the last 2.5 years, how people went to Zoom and not having to communicate directly, people working from home. It's just insane amount of data that you have. So two types of technology that you will look into: servers and clients. Servers is basically where your content is available for you to access, like you guys accessing Canvas, accessing your Gmail through Mod. That's all on a server, and then the client is basically the user that you guys are using your computer to connect to it. So that's basically the whole idea behind it. Server computers have software installed that enable them to provide info, emails, web pages to other hosts on the network. Each service requires separate server software. So you have to have dedicated software that allows you to manage the information. If you have a database one, you need the DBMS. If you have a fax server, same thing. If you have a file server, you need the software for it. If you have an email server, etc., etc. So different communication applications that you'll have to use that allows you to connect and create that network of networks where people can go and utilize them. The figure that we have right here, they're all connected through a switch, which in this case it makes it a switch network that allows to connect through a unit to send and receive information. So they're not connected directly to each other. Client computers are just computers that have software installed to enable them to request and display the info obtained from the server. Like I said, like your computer, you have to go through a browser to connect to Canvas. You put your username, password, which will ping the server that has that information. Do a HTTP GET, meaning to find the latest edition of the HTTP version, the HTTPS. It's probably more accurate, and then from there gives you a copy of what you're looking for. Network infrastructure contains three separate things of it. So three categories of network. You have devices, media, and services. The devices are the equipment, the hardware that you're using, and the can be the routers, the switches, etc. And then through those, you use some type of logical software that allows to connect all of those together. Every hardware must have a software to be able to connect with those. End devices or host the source of or destination of a message. So it goes from one end to the other, um, either using, it doesn't matter what topology you're using, mesh, using hybrid, large bus, whatever. It doesn't really matter. It just you take the information from one place, you send a request that goes on a network from hop to hop until it gets to the final destination. We'll see later in chapters what is utilized. You'll be using your IP address, you'll be using your MAC address, and through those, it'll be able to find out based on the network address of your host, meaning your IP address that you have will look at the network address, and the network address will be determined through the unit itself, like the switch or the router, and etc. Intermediate devices connecting connectivity to and between networks. So it's a connection between networks. You have a LAN, like for example, for us at Mod, we can create in our technology division building, we have 3 floors. So we can create a LAN, separate LAN on its own for floor one, another LAN on floor two, another LAN on floor three. So what do we need? We need some type of equipment. Usually 99% of the time, what you'll be using um, is a router, maybe a bridge router that connects the different floors between each other. So that's what you're using. So example, network access device, hub switches, wireless access points, networking devices, mainly router. That's the main job is of the router is to connect the different LANs together, and then communication server and modems, and then you have, of course, your firewalls, IPSs, IDSs that just try to safeguard the packets that pass through and come to you. Network media, it's just your access cards, the network access cards that you're using that allows you to connect the different types of signal. So either it's a copper using analog, fiber optic using digital signal, pulse of light, or wireless, your access points that use through the air the signal. So 3 main types that you have, either analog using copper, fiber optic using pulse of light, or wireless using electromagnetic, waves. Symbols that you need to be careful about, especially in Cisco. When it comes to Cisco, if you guys decide later to go for your CCNA or CCNT, the first part of CCNA, definitely something that you need to know. The way they look like, what they are, like for example, the symbol for the wireless media, wireless media, WAN media, what that looks like, or a router, how it looks like, or a switch, and etc. Definitely nothing major, but you definitely need to know how they look like. Physical topology diagram, just it's basically the way you lay out your wires. So when you send them from either your telecommunication room or equipment room, or if you have both, if you're lucky in a building to have them, is how do I run my wires? And horizontal or vertical wiring, that's what you'll get. So going through the ceiling, going through a fake floor, going through conduits on the side of your building. It all depends on how the building was set up, and it depends on how you go from floor to floor to connect the network together. Logical topology is just the way you submit the signal. So identify devices, ports, and IP addressing scheme that you create. And we'll see one of the chapters will cover IP addressing that you'll need to be careful about, especially if you, like I said, you decide to go for the CCNT um, certification. A lot of the questions are relating to subnetting. It's dividing the network and in small chunks, the LANs. The smaller the LANs, the easier they are to control. However, on the other hand, the more painful they are because you'll have a lot more LANs to manage on a daily basis. LANs and WANs. LANs is local area network, and then WANs is the wide, so the larger one. So LANs are anything 3 or more computers can be considered as a LAN. Okay, then you can go to 100, 150 LANs, and then from there you connect those LANs together, and then you get a WAN. Question: if we were face to face, I'll ask you what is the biggest WAN in the world? Is the internet. Internet connecting everybody face to face. So tells you, LAN, individual network, usually spans a single geographical area to connect computers together. WANs, wide area, least connectivity connections through a telecommunication, so an ISP provider that you have, and service providers interconnect the LAN at the different locations, so voice and data on separate networks or converged network. And you can see T1 line or DS3, PPA, triple Ps, frame relay, ATM. Mainly, you'll find half a T line or T1 line, half of one T1 line, or just a T1 line to send and receive information. So the internet IPv4 and IPv6. You'll hear that a lot about the need that we have for IPv4. That it got exhausted in the 2010s, and then we have IPv6 that came, which is basically using hexadecimal instead of using just basic binary. So it went from 32-bit to 128 bits. That gives you, I believe, for every user on Earth, we have what, over 7 billion people. You have like 1 decillion possible IP addresses. So I don't think we're gonna run out of IP addresses anytime soon, which allows to eliminate the need of multiple broadcast addresses, which we'll see later. Because now for every network address, even if you subnet that in multiple ones, you only need one broadcast, which eliminates the needs to have multiple ones that you have to deal with. So the internet and network of networks, just the worldwide connection of computers together. You go through an ISP to connect, and the internet ISPs connect to other ISPs, and et cetera, et cetera. From city to city, state to state, country to country, continent to continent. So intranet is within your company. Extranet, it's within the company and just the suppliers or the customers that you have that you deal directly with. And the internet is open. So intranet is closed, is intra, it stays within the company itself. Extranet, it is still closed but open to few connections outside of your network. And then you have the internet, which is worldwide. Connecting residents to the internet, mainly what you'll use fiber optic to connect um, main areas of ISPs to ISPs, and then homes you'll be using basic copper wire to connect them together. So example, you have DSL, cable, cellular, satellite, etc. So depending on your area where you are, you'll get one of those. So connecting businesses to the internet, it's the same idea. The difference is if you're going building to building because of security purposes, then you'll have to use some type of dedicated lease lines, which are like more secure lines. And then you have Metro Ethernet, and then you have DSL, and then based on organization, you might even still see satellites that connect them together. Converged networks, multiple networks. Basically, you have more than one, like your computer networks, you have telephone networks, you have broadcast networks, especially with the evolution of the internet and how it's used for telephone system, VoIP, voice over IP. You don't have like a dedicated system that actually only most companies went to VoIP because it's a lot easier and it's cheaper from a cost point of view. Converged networks, you have rules, agreements, standards, so regulations of sending and receiving information. Based on those standards, they're usually generalized, meaning basically you use them everywhere. You had different protocols back in the days before you have the TCP/IP protocol suite. You had IPX, SPX, you had Apple Talk, you had NetBEUI, you had TCP/IP. So different rules, different regulations of sending and receiving information. However, with the generalization, standardization of using TCP/IP protocol suite, so the umbrella that is everything is under it, the rules are the same to send and receive information on RJ45 connectors, RJ11 connectors, fiber optic connectors. It doesn't really matter. They're usually the same. Reliable network. Network must support a wide range of applications and services, as well as operate over many different types of cable and devices. Basic example, look at IPv6. The government wanted, US government, the DoD wanted by 2015, 16 to have 90% of the companies to go IPv6. We're not even halfway there. So you'll need to be able, your network needs to be able to still handle IPv4, IPv6, analog signal, digital signal, wireless signal. So there's so much that comes to play when you're building a network, and you have to be careful about the quality of service of your signal. So you have to have fault tolerance, you have to be able to be scalable, quality of service, security, which you guys know just from the basic news that we watch how much flaws is there within security. So expectation is that the network of internet is always available to the millions of users who rely on it. Now, that all depends on what type of business you're in, the industry you're in. A banking system will be different than healthcare. Healthcare will be different than automotive, etc., etc. So some will have fault tolerance, meaning you cannot go down. Some of them will have like 1%, some of them 2%, and etc., etc. So fault tolerance, circuit switching, separate circuit for each call. multiple redundant circuit, but only one user per circuit, limited numbers of circuits. So just to allow to eliminate that. The packet one, which packets share the same circuit, multiple redundant circuit, but each circuit is a shared one, limited numbers of circuit, but shared. So that's what you'll see a lot, the packet switching technology. Why? Because even if you have like this picture shows five different routers connected together, meaning what? If I'm going from router 1 to 2, if the connection is down, I can use router 3 to 4 to 2, and etc., etc. So it gives you redundancy, and that's what you'll see from a mesh topology. It's very rare to see a mesh topology in um, as a network. You'll see half a mesh, and that's usually only connecting routers together, or mainly routers and switches, like the units that allows the data to travel for redundancy. That's usually what you'll see. Scalable network can expand quickly to support new users. That you always build a network on the idea that it will grow in the next 6 to 12 months by 15%. Okay, that's the rule of thumb. So if you have a good infrastructure that you build from scratch properly, it will be easy for you to go ahead and create extensions. You're adding more LANs. Okay, you're doing just adding an extension without really disturbing the network itself, and that's very, very critical. Now, if it's a mess and you don't have a good structure, you don't have good documentation, it's not properly done, to add a new LAN, it's a nightmare. So it is pretty easily. That's why when I stated earlier, having smaller LANs connected together, it's a lot easier in a star topology. It's a lot easier to maintain. So from there, I'll be able to just add a new LAN to the network connected to the main switch, router, hub, whatever you have as a unit that connects your network. And then from there, boom, you're up and running. Quality of service, just it's referring to the ability of a network to provide improved service to selected network traffics over various underlying technologies. Meaning, if I'm supposed to get 100 packets per second, hopefully I'm not going to go to like 15 packets per second. I'm still going to be around 100, 92 to 100. It should be reasonable. So that's the quality of service. And if you buy like a T1 line, a dedicated line, they'll tell you it's like 1.5 gigabits per second. They guarantee the 1.5 gigabits per second. So if you do your testing, that's what you're exactly getting. Now, if you get a non-guaranteed one, not a T1 line, then you'll have a variation. So not all data is equal based on the data that you're trying to submit. Data that have high priority will be sent through the queue first, then the medium, then the low priority, and etc. So if I'm trying to print, it's not the same as me sending an email. If I'm trying to print, I don't want to print a page and then I'll send an email, then send a second page, which might end up being lost or not transmitted, and etc. So maybe printing will have priority over the email. Why? Because the email is going to an inbox, which is a waiting area that later can be retrieved. So that's how you prioritize, and network administrators are the one that will decide. Like voice over IP, you cannot afford to have cut lines, like to lose some of the packets. So voice over IP has to go first, financial transmission second, and then finally web pages can be third. You can get like maybe a 403 error when you try to open a web page, meaning what? It took too long, the hops, because in your headers of a packet, either TCP or UDP, it doesn't matter. You have like a time to live on a network, meaning time to live is how many hops can you go before it has to kill the packet, because you don't want it to stay on the internet forever. Security has evolved from tight controlled internetwork of educational and governmental organization to wide access means for transmission of business and personal communication. So security is always a risk that you have, especially think about, like I stated, the online classes, people working from home, going virtual, and etc. It's so easy for data, because data is traveling on the internet. Internet is just an open jungle, basically. Everybody can go on it. Catching packets, it's easy. It's very easy to capture them using just basic software, open source, that are available online. The problem is, can you decipher it and understand what it is? So the idea behind this is to make sure that when I'm connecting on the outside of my network or on the inside, on extranet, or just the internet, I have security good enough that will not compromise my packets. Network trends, it changes. Like for example, bring your own device to work these days. It's very popular, using people using their smartphones and tablets, which is a nightmare because there is no security or whatsoever built in them. Even if they connect to the network that is a secure network, their units are still have so many flaws in them that they can be bypassed and hacked really easily, which is a serious problem. Online collaboration, you guys seen it, Zoom, like us, Canvas, and etc., which is a serious problem. Video communication, so video conferencing is a serious problem that we have to secure and make sure that the transmission that we have is on a secure line. Cloud computing, which is the sexy trend with virtualization, those are the two things that you see and hear all the time. Cloud computing from a business point of view is a genius idea. Why? Because I don't have to save it on. I don't have to save data on site. I don't have to maintain it. I don't have to maintain my hardware. From an IT point of view, is a nightmare. Why? Because where is my data located physically, and how do I connect to it? Those are two main things that you always, always, always have to be worried about. And what are the risks of my data to get compromised? Data centers, cloud computing is possible because of data centers. Data center is just an area used to have like a zillion amount of computers, associated components, including like redundant data communication, high-speed virtual servers, redundant storage systems, backup, power supply, environmental control, like for example for humidity and fire suppressors and etc., and have security devices. So data centers are just they popped up in the mid 2000s until now like a bunch of mushrooms because of the need that we have for people for companies to move away from hosting everything locally in a telecommunication or equipment room and then just hosting and utilizing those clients. So network technology at home, it's basically just using the business idea but at home, going through cloud computing, going through a regular power line networking, going through wireless, and etc., etc. So it's the same setup that you'll have to look into and be careful. However, unfortunately, homes networks are a lot less secure than a regular commercial network because you're not using probably a physical hardware firewall. You're not using IDSs, you're not using IPSs, you're not using honeypots, you're not using a DMZ. All of this is usually not the case at home. It's something that you do in a corporate environment, but not really home. Network security, integral part of computer networking, important on any size. If you have two computers connected, if you have 2,000 computers connected, you still have the same problem. You still have the same risks. Data being compromised, your network is breached, then good luck, you're in serious trouble. That's something that you have to look into. Even for you guys at home, what are you using at home? Your access point, does it have some type of firewall? Your phone. Of every single class that I had face to face, I asked my students, how many of you are using their phones to do online banking? And 90% will raise their hand. If you're not using some type of VPN, that's a big mistake. You need to look at the VPN to connect to your banking system because your phone is just an open door. There is no door actually. Anybody can come in and catch your data, and then that's a serious trouble. Internal threats, most common data breaches happen because of internal users of the network, either lost or stolen devices, accidental misuse by employees or malicious employees. 99% of the time, it's not really malicious, other than the person that get fired and they don't basically cancel their credentials. It's usually by mistake. Someone opening a file they're not supposed to do. At work, people opening their social media on their computers, not just on their phones. Downloading a file, clicking on a file that is a problem, accessing something they're not supposed to access, bringing your own device to work, which might have a malware which can propagate through to your network. Being Having a security policy that is clear and understood by every employee is one of the most critical things you can do on a network. Having educated users, because the weakest link of any network are the users, which are usually just ignorant. They don't do it in purpose, they just don't know. They do, oh, I'm just going to my Facebook account. I mean, what am I doing? I'm not doing anything wrong. That's true, you're not, but clicking on stuff or viewing stuff can put the network at risk. And if um, one person has a problem with the network, then everybody has a problem with it. So solution, from a security point of view, network security components for home or small offices, network should what? At least have a up-to-date antivirus and anti-spyware, have at least the software firewall, which comes with your operating system, At least with if you're using Windows or Mac, you can just set it up, and then use it. At least these software ones, even if you're not gonna invest in a hardware one. Other In the addition to the what we just stated, larger networks should have dedicated firewall systems, should have access control list, should have intrusion prevention systems and intrusion detection systems, and should have VPNs. So those are the basic things that you must have on any network, and you have to be able to set them up. So that's it for week one. Hopefully it'll be a soft one for you guys to get warmed up and ready, so we can have some serious fun. And please reach out to me if you have any questions about the content. I'll be more than happy to assist you in any way or shape. We can always, catch up through Zoom or phone call and etc. Have a great weekend, guys, and I'll see you guys in week two. See ya.